Greetings to all. In this video we will be discussing what changes you will be finding in case of atrial enlargement in ECG. So first of all we will learn from the basics, and then I will draw a representation of heart. So this is your heart, okay, and this is right atrium and this is left atrium. So when the impulses travel from the SA node, they move uh, throughout the atrium. So when we take the resultant vector, suppose if the resultant vector of right atrial depolarization will be faced to this direction. Similarly, the depolarization vector of left atrial contraction will be in this direction, and when you take the resultant vector, then the resultant atrial depolarization vector will be in this direction. So up to here I hope it is okay. Now once again let's recall our lead diagram. That is, this is lead 1, this is AVF, and you can see this is lead 2 and this is lead 3. Here we have AVL and here we will have AVR. So when we take this vector, that is the resultant vector of atrial depolarization, which is in this direction, and when you compare that with the lead, then you see the direction of this atrial depolarization vector is same as the direction of lead 2. So by that what I mean to say is that, so here the atrial depolarization vector direction will be alongside lead 2, because this will be lead 1 and this will be lead 2 and this will be lead 3. We had discussed already. So when you see the direction of atrial depolarization vector and the lead 2 direction is same, so the atrial depolarization will be least picked by lead 2. So always, to find any atrial pathology or to see the P wave, it's good to look for lead 2. So this we have discussed, which lead to look mainly, and then again discussing about atrial depolarization. Suppose this is your right atrium and this is your left atrium, isn't it? So when there is right atrial depolarization, it is represented like this, and left atrial depolarization, it is represented like this, and its resultant in ECG, it is seen like this as a resultant. So in normal case, so this will be our P wave, and we have already discussed in previous videos that criteria for P wave is the height of P wave. The height of P wave must be less than 2.5 square box, small square box, and the length occupying by the base of the P wave is also less than 2.5 square box. So this is the normal criteria for P wave. So normally P wave will be like this, and we look at lead 2, and another lead to be looked at for atrial pathology is lead B1. So why lead B1 is important is that I will draw here another example, a representation of diagram. So this is the cross section, and when you see our heart is been represented like this, and you have your B1, B2, B3, B4, B5 and B6. So this is your right atrium. So right atrium vector will go in this direction, whereas your left atrial depolarization vector will go in this direction. So you see this V1 is the direction. So when right atrium depolarizes, it is picked up positively by lead V1. So in V1, the P wave will be like this. Suppose this is your isoelectric line, then this is because of your right atrial depolarization. And since the left atrial depolarization vector is in opposite direction to V1, so it will have negative deflection. So in V1, it will be like this. So normally, in case of V1, so in case of lead 2, suppose this is your isoelectric line and this is your isoelectric line, then normally in lead 2 it will be positive deflection, whereas in lead V1 it will be like this. Okay. Now suppose we have the case of right atrial enlargement. Suppose right atrial enlargement is there. So if there is right atrial enlargement, let's say this is your atrium, this is right atrium, this is your left atrium. So when this part is enlarged, then you see the resultant vector of this will be greater than the resultant vector of left atrial depolarization, because it is enlarged, so muscle mass will be more, so the overall vector will be more. So when you see, initially we have talked, suppose this is in normal case, if this is right atrial depolarization and this is left atrial depolarization, then in case of right atrial enlargement, this will be bigger in magnitude than the left atrial depolarization. So the overall vector will be, overall P wave will be of this much magnitude, whereas in case of right atrial enlargement, due to this enlargement, we will have tall P wave. So this tall P wave will be greater than 2.5 small square box. So this thing you need to keep in mind. So what we will have, suppose if this is isoelectric line, then in lead 2 you will be having tall P wave. However, in case of lead V1, in V1, here you see this is lead V1. Suppose this is your right atrium. When this right atrium is enlarged, then this vector will be greater in magnitude. So the greater magnitude vector is facing towards V1. So the positive deflection in V1 will be more. Suppose this is right atrial enlargement, then in V1, here initially normally it was like this, but in case of enlargement, the vector will be more, whereas left atrium will have small deflection. So the criteria is the enlargement seen in V1 is greater than 1 small square box. So in lead V1, what will be the difference? The difference will be the positive deflection will be greater in magnitude, that is greater than 1 small box, and small lower deflection, negative deflection. Now again, when we talk about left atrial enlargement, so again we are taking this left atrium. Suppose now this left atrium is enlarged. So if left atrium is enlarged, then the magnitude of vector of left atrial depolarization will be more. So as we have already discussed, normally what it was, normally it was like this of right atrial enlargement and like this of left atrial enlargement, left atrium. However, in case of enlargement, so this will be more. So what kind of resultant ECG P wave you will be finding is, it will be like double peaked P wave will be seen, like this double waved P wave will be seen, and the time will be greater than 0.12 seconds. So in case of lead 1, in case of lead 2, in lead 2, in left atrial enlargement, you will be having double peaked P wave. Similarly, in case of V1, suppose this is your now left atrial enlargement. So this is your left atrium. When this left atrium enlarges, this vector will be greater in magnitude and it will have deflection negative because it is opposite to V1. So in normal case, the deflection was like this. In normal case, the deflection was like this in V1. However, when left atrial enlargement will be there, this vector will be increased. So, and again it will be greater than 1 square small box. So, in lead V1, the changes you will be finding is this positive deflection will be normal. However, the negative deflection will be greater in magnitude, which is greater than 1 small box. So these are the changes that you will find in case of atrial enlargement. Once again, quick revision. Why to look for lead 2? To check for P wave, because the direction of atrial depolarization and the lead 2 direction is same. So the maximum nicely lead to picks of the P wave morphology. And lead V1 will be helpful because, as we have already discussed, when we keep the heart like this cross-sectional diagram, right atrial enlargement will be towards the V1, left atrial enlargement will be against. So in case of normal case, S-shaped or biphasic P wave you can find, and in case of enlargement, the respective representation will be enlarged. Suppose if it is right atrial enlargement, then this will be bigger. If it is left atrial enlargement, the negative deflection will be bigger in V1. So this is the basic theory.